Hi guys, so in this video I will be looking into control statements, what they are and how you use them to direct the flow of your program. So without further delay, let's get started. So let's create another file. Let's call it control.cpp, and yeah, so let's include C Studio and create an increment as we usually create a program. So the first control statement that I will be introducing to you is called an if statement. So how you write it? It's very simple. So you have if and then you give a condition. And if the condition is true, then whatever after if is given, it will be executed. And that's it. Now you can extend this if statement by saying that if that condition is not true, then you put an else and whatever is written after else is executed. Now you can give a block of code that you want to be executed after if by providing that inside this curly braces. That is one way. But like if you have a single statement, you can also like put a sorry, you can also put a statement like this, like for example, uh, print f is executed, and if it's not true, then print f the else is executed like this, for example. And obviously, you need to like end the statements using semicolon in case you are programming in C++. Now, a condition, it can be a boolean or anything. It can be an integer. It can be because like at the end of the day, it's just numbers. And the only condition is that the condition has to be true. And true means that anything except zero. So, for example, let's say int condition and let's set it to -1, or for now let's set it to like 100, for example. And if I run this statement, so I will compile this. uh, yeah, so stdio, I don't know why I'm every time writing this wrong, but yeah, like if I compile this and then I say in case of clang it will be like a.exe, I think, by default. So you can see that this statement is executed, right? Now coming back to this, uh, if the condition is let's say -1, for example, and if I try to compile this and run it, you can see that this statement is executed. The only one statement that will be that will be like considered as false if the value is zero. Okay, so like if I compile this now and if I run this, you will see that the else statement is executed. Okay, so and like as long as it's a zero, it's fine. Like even if I use like something like float, okay, and let's say this is 0.0 f. Uh, when I will be talking about variables, I will go deep into it, like how the memory are constructed and so on. But like if I run this, you can see that the else statement is executed. But like the normal case scenario is that people usually declare a boolean. Okay. The boolean is a type that can have two value, either true or false. So it makes more sense. So like you can say if condition is true, then this, or you can say condition is false, then something else. So I can also compile this and I can run this. And you can see that this statement is executed is done here. Now in your program, every if is a control structure of its own. So let's say I have another if statement here, and in this case also, if the condition is true, this is executed part 2, and this is executed, the else is executed part 2 here. Uh, let's create another one. So in this case, if the condition is not true, so I can put not here. So this means that because my condition was true, because of this not operator, it will become false. So in this case, the third case, the else will be executed. So I will put 3 here, for example. And if I run this, you can see that in this case, this statement, I think I should put a new line. Just one second. Should not take much time, I guess. Yeah, backslash n, backslash n, backslash n, and so on. So now if I, let's say, compile this and try to run this, you can see that in first case it was executed, and the second case it was executed, but third case it was in like not if. So in that case, the if statement was executed false, so the else was executed. The idea is that the first true that is hit in a if else chain is executed. Now what I mean by chain is that you can add multiple conditions. For example, if you have like multiple things to check, and depending on like what is the true condition that is hit first, you want to execute some code, then you can do that. For example, let's say I have an age of a person, and that age is something like, let's say, 20 or something, and then I say if the session is good. So if the age is greater than 18, then you are an adult. If it's greater than 12, then you are a teenager. And if it's um, let's say that doesn't hit the above two cases, that means that the age must be below 12. So we can guess that you are a child. Now I don't want to like every time do it. So what I would like to do is I will create a function. So void check age, for example, and it will take int age, and it will just do the whatever is written down below. So now what I can do is I can test it for multiple ages. So I can just check age for, let's say, 20, and then I can check age for 15, and then I can check age for 10. Okay, and now if I let's say compile this, I got some error. We can fix that. And I have a extra parentheses here. Let's remove that, and let's compile this. And then if I let's say run this, you will see that 20 was an adult, 12 was a teenager, and obviously the age 10 was a child, and so on. So that is about if else statement, but you need to understand one thing, that else if is not an actual statement of its own. It's just because after else, whatever you put, a single statement that is executed. So this basically is this, like if and else, and everything after that is inside this else. Okay, so this is what's going on actually. So you might think that else if is another keyword, but it's not true, because that statement and this statement is almost equal, right? And the only difference is that because this is a single statement, I don't need to put a parenthesis, and after else if I write this, it will be considered as the same. So like even if I compile this and I let's say run this, I get the same kind of output, that you are an adult and teenager, so on. So let's clear the screen for a bit, and let's understand what happens when an if else this kind of statement is executed. So in the first video we talked about controls, like we talked about like executing micro instructions. Whenever your program is compiled, it creates a bunch of zeros and ones and so on. The spaces are not there, and these are probably like 32 bits, not like 5 bits here. But for the sake of simplicity, and like as a human readable script, it will be look something like this, like add 20, 10h, 30h. Just I'm just writing a like demo code. You don't need to like judge it. But okay, let's say write it like this. So add 10 and 30, and then let's add 20 and 40, and add 30 and 50, and so on. And what happens is that whenever you do these kind of operations, okay, let's make this subtractions and so on. So after this the whole thing is computed, the result usually is stored in the accumulator register. And the idea behind it is you in your accumulator register, the value it can be used by some other instructions, micro instructions present in your ROM, and they decide the flow of your control. So like these particular instructions themselves, they are situated in some place of your memory, let's say at like 3000 position of your and then this is, let's say, like just this is for example, this is not like actual binary or actual assembly, because it will not make like too much sense to like go into that when you are learning if else. But the idea is that like you can see think that in your memory at 3000 position this statement was there, at 3001 position this statement was there, and then in 3002 position, because your memory is a single continuous line of data, so you can think of it like these in these positions these statements were there. And then after this statement was evaluated, its results are always stored in a special register present in your CPU called accumulator. And you can query that statement, that value that is present in the accumulator, and you can ask that in like 3007, I can say that jump if 0 or jz, and I can say that to like let's say I can say that jump is 0, and then I can give like I can use the accumulator. I am not using like actual assembly statements here, just to make the point. And what I am trying to do here is say that whatever the value in that register is, if that value is like greater than is equals to 0, then in that case go back to this line, and like that is the idea behind it. Like for example, in this age example, like in this age example, I had uh let's say a value as like I had loaded I had loaded the like I had some age declared somewhere in my program. Like in let's say in 3000 line, there was a value stored, and that value was, let's say, the age that I had. For example, I'm not writing a real like machine code or assembly once again. Just this is an example, and that age used to be 18. Now, what my program was is that said that in let's say in 3001 there was a statement that load age, and that age was loaded in the accumulator. And then I had in some other places like this print statement, it itself is triggering some functions, and let's say that function was somewhere around 5000 place, and that was a print statement. Okay. And the rest of it contained all the code that used to it is used to like trigger the printf and so on. And what happens is that in after loading to the register, I was checking once again, I'm not writing a real assembly or anything, just for sake of understanding. This is an analogy, but it's very close to what is happening. Is that I'm asking that if it's not zero, so jump if not zero uh, to, let's say, 3003, and in 3003 the statement was that I wanted to call printf. Once again, this is not like what is actually happening, that you are an adult. Okay, so if it was not uh, if it was not zero, in that case this was hit because the age was there. Okay, and this is what happening. And like if it's not zero, then do this. And if it's zero, then you can just simply you can just simply say that in 3000, let's say this is 3003 and this is 3004. And in 2004 3 it was like okay, let's call printf that you are a child, and so on. Okay, this is just an example. I'm not like also going through this, but the idea is this: like if this statement, and after this, let's say this was 3005, and the statement was here is that in 3004 it was like just go to 3005. That like it was like just go to 3005, 3006 for example, because like this will be 3005 and this is 3006 in, let's say, your memory. And you can already see the problem that it's very hard for humans to write instructions like this one for one for very complex programs, and that's why we tend to use some higher level languages than assembly, like C or C++. But the idea is that this is how the whole thing is executed, nothing else. And the same thing is also used in loops. Like you execute some instructions, and then you compare something, and when that comparison value is either 0 and 1, depending on that, you jump to some other place of your code and call this thing. This call actually is, I think, is also call in assembly. Call is just like you have different procedures that are inside your memory at different locations, and you just want to have some variables passed to that procedures. Those variables basically, that means is that those variables are set to some particular registers. The values that were already in the register, they are pushed to some like stack, and the stack pointer is then changed. And then the like I will explain it later, but the idea is that then whatever that procedure is, that call is executed. And once that call is done executing, the return statement is triggered. And when the return statement is triggered, it the control flow goes back to the next line, and so on, and it keeps on executing. Like in the computer itself, this is what is happening. Okay, so you need to understand that. But as for humans like us, it makes more sense to write something like this. So, like, that is it. There is nothing else. And you can, in the previous video about operators, I have also shown you that you can use trinary operators to kind of get the same kind of vibe going on that is also being done by if and else. So that is one. Another is that you have a switch statement. Let's say int count, and let's say the count is let's say count is 0 or 1 for example. And then you can create for, let's create another function void let's say switch statement, switch statement, switch statement. And in this to switch statement, I can do something like this. I can take a count from here. Let's say I take the count, int count. It takes the count, and then it switches on that variable count. And depending on the different values that matches to that particular count, the first one that is true is triggered, and then this break keyword is used. the cases they define the values. You cannot give conditions here, but like the values themselves are given here. So if the cases 1 and 2, like 1 is true, then in that case the statement will execute, and then there is a break. Whenever there is a loop, or there is a conditional statement, etc. Basically, something that is enclosed inside a scope that is presented by these parentheses. Whenever this break statement is seen by your program, it directly jumps outside that parenthesis. Okay, nothing else. So what it means is that switch on this count and like keep on going through one of these cases one at a time, and whenever you trigger one of any of these statements, these values which is equals to this, whatever code is inside it, uh, just keep on running. So in this case, like inside also doesn't make any sense, because like whenever that case is triggered, the rest of the code will be executed, and because there is this break, it will go out of this bracket. Now you can experiment on Switch. You can go to internet and you can see some examples. But I will give you a good example that will make any sense. And that is I will check uh, character, whether it's, let's say, uh, character C, and I want to check whether that character is a vowel or a consonant. So I know that there are five vowels, that is A, and that is B, AE, sorry, and there is I, there is O, and there is U, right? And out of this, whatever is true, that will be executed. And obviously, you need to put the break. Unless you put the break, what happens is that it goes out of the flow, like it keeps on running the next statements. So the next cases and their statements will also be run. But the case matching is no longer necessary. Like for here, you can see, like if E is triggered, then also the statements that are put after it that are not cases will also be triggered. So I think this is a good example that shows you like how they are actually used. Okay. And let's say I put a special character like case Y. Uh, let's say it's a semi vowel. Okay. Like for in case of W and let's say Y, just I don't actually like remember right now what are the semi vowels, but for example, say. So now we can check it. Like I can say check character for a bunch of characters. Like I can check for A, I can check for B, I can check for W, and we can compile this, and then we can run this. If I can find the current executable, and you can see I didn't change the statement, so I can change the statement here that this is a consonant. So I can say that this is a consonant. If my spelling is not right, then just go through it. But that is it. Like the first A, it was a vowel. The second was B, it was a consonant. The third was W, it was a semi-vowel. And the program executed as I wanted. Okay, and this is the switch statement. Okay. And once again, these things are directly compiled into those like jump statements that I showed you. Uh, and you can just go through the internet and you can exactly see what is happening. There are some like websites which just allow you to convert the code into like straight up assembly code. So you can look into that. You can even compile the programs into assembly, but we will see that in some other videos. Okay. So we have done going through if and switch as far as I remember. Now let's talk about loop. Loops are what? Loop is nothing but you keep on doing the same thing, repeating the same code again and again until some condition is satisfied. That is what a loop is. For example, there are some loops. One is for loop, very popular for a loop, that is there is while loop, and there is also do while loop. So let's first work with the while loop. So in while loop you have, while the condition is there, this loop will keep on executing. For example, print, uh, let's say printf a, and then some apostrophes and then backslash n, for example. And this condition, I can say that I have an integer, and this while loop may keep on running for infinite times, but I can specify a condition here that while I is less than 10, for example. Okay. And let's set I to 0. And obviously, because this condition is true for every time, like this year, after this year, this i's value will not change. So this will keep on running infinite times. So what I need to do is I also need to change the behavior of the I. For example, I can keep on incrementing I, and so that the I is actually being implemented, I can just pass I to let's say printf, right? So this looks good, I guess, and also captures how the file statement works. So, uh, except that I came back to the editor. But if I run this, you can see that until the value was 10, this statement was executed, right? So that is what while does. And the same goes for do while. So I will just take this and I'll just put it here. Except in case of do while, what happens is that the while is at the end. So you can be certain that at least one time this will execute. Like at least this code will be executed once. For example, and then the while condition will be checked. Okay. So that ensures that this statement is executed at least once. For example, my I starts at let's say 20. So in case of a typical while loop, because the condition was checked and it was found to be true, the code will never be executed because it was false from the beginning. But in case of do while, it makes sure, and obviously I need to put do here, it makes sure that at least once this will be executed. Okay, I so it's some error. So just yeah, and after this, in do while you put the semicolon after while. But if you compile and run this, you can see that that statement is at least once executed, although the condition of the while was false. And after that, the while condition was checked, and it was found that it was false, and so it didn't execute any longer. So that was do while. But most of the time, and most of the people, they prefer to use the for statement. And the for statement is very simple. You say for, and then you give an initialization, you give a condition, and you provide that after the condition, what update is to perform. Okay. And that's how the for statement is executed. For example, let's say I want to find the for let's say I want to find the sum of the numbers that are like sum of the first thousand mm, even numbers, like the first 100 even number, or like first the I want to get the sum of the even numbers that are below, let's say 400. Okay, I can do that. So I can have an initialization statement, like I have an loop variable I. We just call these loop variables, whatever you want to call it, but it's just that this I will be available only inside this. After you get outside of this for loop, you will not be able to use this I again. So for I equals to 0, and also you can keep these things empty also, like it doesn't really matter. And while I is less than or equals to, let's say 400, 400, what I want to do is I want to keep on adding I to the sum. So sum plus equals to I. And I can put I plus equals to 2 there and keep that like that update field empty. Or I can just simply say I plus equals to 2 here as well. So after that, let's printf this thing. And if I run this, you can see that the sum of the numbers from 0 to 400 is 4200, right? And what I told you earlier, let me show you. Like I can keep one of these fields empty as well. So I can declare the I outside. Like I can say int I equals to 0 here. So I have already initialized. I don't need to provide this thing. I just keep it blank and put a semicolon. And also I can like keep this field as a empty as well. I can say that I plus equals to 2 here, and it will act just fine. Okay, so you can see that the result is same, and it's also true for this statement. So you can always put empty statements if you want to like feel like you don't want others to understand whatever you are doing. Like you can put empty spaces here. That also doesn't do any change anything, but like then people will just think you as a madman. But apart from that, you can also do like this, like yeah, like I will put the condition here that if I is greater than 400, then just break. Okay. And this is also very like this has also the same kind of behavior. If I run it, you can see that this it also acts the same. So one important understanding that you can get from here, like this kind of for loop, is that uh, the you don't have any particular constraint of how you need to code. You can code however you want, and you can take leverage of different behaviors. You just need to know that certain statements or certain words act in certain way, and the rest is up to your imagination. Okay, so that basically covers all the loops. I think I have gone through the if statement and switch statement and a few loops that are available here. So I think that's a good point. But yeah, so let's wrap it up by writing a small program that makes sense. And I want to find all the prime numbers that are below, let's say, 1000. Okay, all the prime numbers that are below 1000. So what I can do is I can create a function that is of type boolean because it's going to return true or false, and I will call this is prime. Okay, and this is prime, it will take an integer, and what it does is very simple. As it has written for me, I'm not going to write, keep on wasting my time to write it, but just understand this is the condition of being prime is that when a number can only be divided by itself and 1, it is considered as prime. So what I need to check is after 1 comes 2, so from 2 to the till the number is reached, and like you can optimize it by saying that okay, I don't know need to reach the whole number. I can also reach the I can also check the numbers that are like below or equals to the square root of that number, and that's where this I times I comes here, because I times I is equals to n means I equals to square root of n, and you keep on incrementing I. Some people like pre-incrementing, some people like post-incrementing. It does not make any sense, but like in general, I prefer post-incrementing. Okay, and then you check if you divide that number with I, this number that I have passed here, its remainder is equals to 0. Then you return false, and like whenever your function returns something, then it gets out of this function. So like I am, let's say I have passed 4, and like I is equals to 2, and in case of I is equals to 2, if you divide 4 by 2, the value will be like 0, right? And so this statement will be true, and whenever this statement will be true, the false will be returned. So after 4, like after the value of I is equals to 2, I is equals to 3 will never be executed. I don't say that this is the most optimum way of finding the prime, but given the circumstances, we can deal with it. So now what I need to do is I need to print all the primes. So what I can do is I can say for here int I is equals to 0, I is less than 100, I plus plus, and if the value is prime, so if is prime I returns true, in that case print whatever the value of I is. Okay, and this program should efficiently give us all the prime numbers below 100. I don't know, I don't remember whether I had yeah, so it's below 100. So you can see that 2, 3, 5, 7, 11, 13, 17, 19, and so on. The prime numbers are printed. Now, like getting all these things dumped at the same times may feel like odd, but goal of going through this series is that I just want you to understand that you need to go through internet and some books and understand those things. My goal is to introduce you that these things exist, nothing else. Okay. Another keyword that I with which I will like to close this demonstration is continue. So and the continue is a very good statement. We can look into it. So and also I will go through go to, although like it's not recommended, but like at any point of time, if something is making your life easy and it's not like that like much like used as a very bad habit, or like your code becomes unreadable, I think like you can use any kind of tool that is in your arsenal, and you can make the most out of it, unless it jeopardizes the performance, or if you're working in a team, it jeopardizes their efforts, and it makes things difficult for others. You can do it. Like, people will say that this is a good practice, this is a bad practice. Just don't go to it. So what I am going to do is I want to say, obviously I need to put print the I here so that I know that which particular value of I is being used when this is executed. And I just want to say that if I is equals to let's say 3, I just want to continue. Okay, it's as simple as that. So if I run this, you will see that the 3, particular for the 3, it will be omitted. Sorry. Mm, let's uh, let's clear the screen for once. So if I compile this, and then if I try to run it, you can see for 3 the for loop the statements after the continue were skipped. Okay, so 0, 1 was there, 2 uh, was there, 3 was skipped, and so on. So we can end it with go to and make these things a bit more clearer by putting here that you can print here that inside for loop. For example, like you can write that I am inside for loop, and so that you know that the statement that is before continue is there, and I just want to like declare I here that int I is equals to 0. Okay, and obviously I don't recommend doing this, but for the sake, and I can like in just like cases in switch statement, I can put a label here. I can call this I am a label, and I can say that if let's say for some reason I is equals to 5, then go to I am a label. Okay. This is the most stupidest thing to do, but just to explain to you that this is also possible, and it will trigger an infinite loop. But when you are learning, it's fine to do experiments. And if I get out of this program, you can see that the 0 was executed. Like we start from here. So 0 was executed, 1 was executed, 2 was executed, 3 was skipped because of the continue. Only the statements before the continue was executed. Then 4 was executed, and then when it match the 5 was matched, it went back to the that statement where I said that I equals to 0. So I just went back to my program. Okay. So this is what goto does. It takes you to that particular line. Okay, it's very unsettling, but there are also like some good use cases of goto. For example, let's say you have I can give you one example also. Like int I equals to, let's say, 0. Like whatever it gives us, it doesn't really matter. I just want to show you like a good use case of goto. And also, like if you want to add some additional conditions and break out of here, you can do. But the problem is that you have a for loop, let's say, and you have another for loop. So like it j equals to 0, and you just keep on printing I times j. Okay, that is your program, right? And like here, if I compile, it throws some error because it likes to make things difficult for me. Maybe I don't know. And sometimes, like, although you're coding for a long time, finding what the problem is without using a good compiler can become harder. Okay. So it says that use of undeclared identifier I. Okay. So that's a good hint. We can respect the compiler that there was a use of undeclared variable I, because I was used, but I was never declared. So always you need to declare your variables, identifier, whatever you like to call them. Okay. So now if I run this, you can see that all these different values, they are printed, right? But I don't, let's say I want to like stop at some point, like here, if let's say if let's say I is equals to 5 and j is equals to 5 for some reason. Okay, I just want to not only break out of this inner loop, but I want to break out of this like this whole for loop ordeal. Okay, like you can break out of here, then you can set a boolean variable here, and you can like set that boolean to false. Like I can show you. Like one way of doing it will be like this: bool leave equals to false. And in this for loop, after the second for loop, if this condition is true, I will get out of this for loop, and if then leave, I will get out of the other for loop. Okay, so I keep on spamming booleans, and like if there are more for loops nested with each other, when you like put another statement inside a statement, it's called nested. So that's why like else if state if else loops are also called nested if else's. But the idea is that you can get out of this, and if these for loops keep on going, so you need to do a lot of breaks. So rather than doing all these breaks, what you can do is you can use that same go to hack. You can just say that okay, go to, let's say, out of loop. I'm just keeping it caps. You don't need to like put it in caps. You can also use small letters, but I'm just showing you a like a valid place where you can do steps. So now, if you run this, and before that you need to compile this. But now, if you run this, you can see that in the previous instance, it went. The last value was 81, and there were a lot of values computed before that. In the second step, when I was equals to 5 and j is equals to 5, it went out of the loop. Like whatever the condition was, I don't remember, and it just print out that it just kept on executing the rest of the statements. So I hope that this gives you a good understanding of the all the control statements that are there in C. And in general C++, these are also the control statements that are available there. I just want to like clear the concepts that are related to C. and that are common with C++. Before like jumping into C++, streams and all those stuffs, STL and stuffs, classes and so on. So that's why I'm just going through this approach. But hope that this gives you a clear idea of what are there available for your control statements. And that's it. If you like this video, please leave a like. And if you have any kind of questions, doubts, you can also comment. And like your support is greatly appreciated. And I can keep on going, blah, blah, blah. But that's it. So thank you guys and bye.